Okay, this is the last question here, and what do they want us to do? They want us to use this property up here. It's not a property, I guess it's a relationship here. They want you to use this formula to make this question easier. Now, when I did it, I don't know why, I just couldn't, it wasn't clicking with me, and I did it another way. I looked at it and I didn't see the simple thing, and it's actually quite good. So, but you see 4x, the sine of two angles added minus the sine of two angles subtracted equals this simple thing, 2 times them multiplied together. How can I use that? Well, 4x is 3x plus x. 2x is 3x minus x. I don't know how I missed it, but I did, and I did it a different way. But let's just look at that. Well, if that's true, then it should equal 2 times the sine of the first angle, the sine of x, you see b plus a, the sine of x times the cosine of 3x. 2 times the sine of the second angle times the cosine. Hey, that makes things pretty easy, because that means the only way this is going to be equal 0 is if sine x equals 0, or if cos 3x equals 0. Now, I saw their memo is a little different than mine. I know that x, the general solution, is 0. Sine x is equal to 0 plus any multiple of 180 degrees. Well, that's the general solution. And for 3x, I know that what makes 3x, what makes a cos 0? Well, it's plus or minus 90 degrees. That's where cos x is equal to 0. And it repeats itself, k times 360, like that. Well, that's one way of doing it. So 3x equals plus or minus 30 plus k times 120. I like to get the general solution like that. But what are your three answers? Because they gave this range between 0 and 90. Well, we've got 0 here. That's one of the solutions. 0. That makes it 0, so that works. We've got 30 degrees. That makes it work. We've got 30 degrees that makes it work. And we should have 90 degrees that makes it work as well. But something is a little funny. But there you go. There's your solution. I just noticed something. Oh, no, it does make 90. See this minus 30 plus 120? That gives you that 90 degrees that works. Now, if you look at the way I did it, I don't know why I couldn't see that simple relationship, and I did it differently. I took a look at it and I went, okay, the sine of 2x is, I left it as the sine of 2x, but the sine of 4x is 2 times, and I used the double angle identity. Then I factored out sine 2x times 2 cos 2x minus 1. I factored it out, then cos 2x equals 1/2, and sine 2x equals 0. But then when I looked at my general solutions here, and I did cos x is 60, I still got 30 and minus 30. When I got the general solutions, I got exactly the same answers, 0, 30, and 90, doing it this way. So I guess you can do it both ways, but they're actually right. It's so smart. In one step, you get straight down to the solution. So it's smart to use what they said. I just didn't see it. Okay.